Hello, thanks for joining us on Astronomy Daily. My name is Andrew Dunkley, your host. Great to have your company. And we also welcome Hallie, who is our AI reporter and provides us with all the news. Hi, Hallie, how are you?
Fine, thanks, Andrew. I've been talking with your brother Steve about upcoming episodes.
Oh, yeah, because I'm taking a little break, so he'll be doing Astronomy Daily while I'm away. How's that going?
He sure does like to talk, and he can't keep his hands off my buttons.
Oh, okay. Anything you'd like me to do?
Oh, no. It's okay. I'm talking about the instrument panel. He loves to play with the technology.
Yes, he does. I do know that. And being a musician and having all the bells and whistles that go along with recording music, yeah, I know he's pretty good at it too. So he'll be helpful, Hallie. He will, truly.
We'll see about that, I guess.
Yeah, well, I'll be away, so won't be my problem.
The Astronomy Daily Podcast
with Andrew Dunkley.
Let's get the headlines, Hallie.
Amazon and Telesat have finalized spectrum arrangements to keep their planned satellites in non-geostationary orbit from interfering with each other. Both companies have told the FCC that the coordination deals ensure the coexistence of their broadband constellations. Both constellations plan to use Ka-band spectrum to provide broadband services to user terminals. Amazon secured a spectrum license for its Project Kuiper network as part of the FCC's 2020 NGSO processing round, while Telesat's Lightspeed was processed as part of an earlier 2016 round. Neither company has started deploying their NGSO constellation, although Canada-based Telesat launched a prototype to low Earth orbit in 2018 on an Indian PSLV rocket. Speaking of Canada, the Canadian Space Agency has signed a significant memorandum of understanding with Axiom, which may see the Canadian Space Agency fly hardware and astronauts aboard SpaceX spacecraft in the not-too-distant future. A memorandum of understanding has been brokered with Houston-based company Axiom Space. The MOU means that potentially, for the first time, CSA astronauts could fly to space on something other than a government spacecraft, and that they may get rides to orbit more often than we've seen in a long time. Axiom representatives indicated that the MOU covers possible flights to the International Space Station, ISS, and the company's own planned free-flying outpost, called Axiom Station. There's also potential for Canadian astronauts to fly on future Axiom-sponsored missions. United Launch Alliance recently completed a countdown dress rehearsal and installed a classified spy satellite payload on top of a Delta IV Heavy rocket at Vandenberg Space Force Base in California. This was part of preparations for liftoff on Saturday. The top-secret spy satellite on top of the Delta IV Heavy rocket is likely a new sharp-eyed electro-optical keyhole-type imaging platform for the National Reconnaissance Office, according to independent analysts. But the NRO has not disclosed details of the satellite, keeping with the spy agency's policy of not commenting on details of its missions. The mission Saturday is codenamed NROL-91 and will mark the final Delta IV launch from Vandenberg. It will be the third-to-last flight overall for the Delta rocket family, which ULA is retiring in favor of the next-generation Vulcan Centaur rocket. It looks like another player is about to make itself a part of the space race. Saudi Arabia is planning to launch 2 astronauts to the International Space Station aboard a space capsule from Elon Musk's SpaceX, becoming the latest Gulf nation to strengthen ties with private U.S. space companies. Sources, speaking anonymously, said the deal was signed privately earlier this year with Houston's Axiom Space, which arranges and manages private missions to space on U.S. spacecraft for researchers and tourists. Under the deal, 2 Saudi astronauts will ride SpaceX's Crew Dragon capsule to the space station for around a week early next year. The selected Saudi astronauts would be the first from their country to go into space aboard a private spacecraft. And lastly, Andrew, some news from Down Under, aerospace company, Virgin Orbit has signed a memorandum of understanding with Wagner Corporation, one of the regional Australia's most successful privately owned companies and proprietor of the Toowoomba Wellcamp Airport and Business Park in Queensland. The agreement will allow the companies to begin implementing a national launch capability from Australia, with the goal of providing satellite launch services from the Toowoomba Wellcamp Airport using Virgin Orbit's Launcher One system. They hope to be able to conduct a launch demonstration as soon as 2024. And that's the news, Andrew.
Thank you, Hallie. We'll catch you before the end of the show. Now to some other news, and Mars is a planet we talk about quite often, and there's been some news from the InSight mission. Now, this was a mission that was launched, 4 or 5 years ago, landed on the planet in 2018. InSight is a probe, if you like, that landed on the planet with two goals. They wanted to put a probe into the planet's surface to see if they could learn what was happening inside, get temperature readings. That unfortunately failed. They couldn't hammer it in properly. They had a few issues with that. The other thing, though, it carries is seismographs. Well, they've proven to be exceptionally successful, and the latest is that they have not only detected, they have identified and located the points where meteorites have struck the surface of Mars. As Fred Watson explains on Space Nuts.
If something comes from space, a meteor, which is zooming through the atmosphere, and is going to be a meteorite because it'll land on the ground, Mars's atmosphere is only 1% as dense as the Earth's. And so it behaves in a different way, plus the fact that it's made of carbon dioxide mostly, which is different from what we've got. So meteors behave in a different way. And quite often you get a double bang, two sort of explosions. One which is called the first airburst, and another which is called guess
the second airburst.
Oh, well done, Andrew. Well done.
That was hard.
Oh no, it's hard work, isn't it? So you get these two, and they send acoustic waves down to the ground, which vibrates the ground.
Yeah.
And it's the timing of this. It's all about timing. So InSight detects the vibrations in the ground and does it very accurately with timing. And it can also sense the direction as well to some extent. So what you've got is a direction and a distance to these two airbursts. And that means you can then plot a trajectory for the incoming meteorite, and you can get an idea of where it will have landed.
Wow.
And they've actually been able to do this and then used, the Mars Reconnaissance Orbiter observations to actually look for the new craters.
Very clever science indeed, and you can hear the full story on the latest edition of Space Nuts. Just go to our website, spacenuts.io, and click on episode 323. Now, following up from some close-up images of Mars taken by the James Webb Space Telescope, it has once again given us an example of its capabilities with its first image of Neptune. Now, not only did the telescope capture the clearest image of the planet's rings in more than 30 years, its cameras also showed the ice giant in a whole new light, including amazing new images of the planet's rings, some of which have not been seen since Voyager 2 zipped past back in 1989. Now, in addition to several bright, narrow rings, the image clearly shows Neptune's fainter dust bands. Now, according to Heidi Hammel, who is a Neptune system expert, it's been 3 decades since we last saw faint, dusty rings, and this is the first time we've seen them in infrared. The James Webb Space Telescope is extremely stable and creates precise image quality, which allows these very faint rings to be detected so close to Neptune. James Webb continues to awe-inspire us with its capabilities. That said, there may be a little problem with the James Webb Space Telescope. Its ultra-cold camera has experienced a bit of an issue, a glitch of some kind that's forcing the ground team to postpone some of its observations. Apparently, the issue affected the telescope's mid-infrared instruments on what's called the grating wheel, which allows scientists to choose the wavelength of light that they want to focus on. The wheel is used in only one of MIRI's 4 observation modes, the medium resolution spectroscopy mode, in which the camera takes not images but light spectra or fingerprints of light absorption of the various chemical elements in observed objects. So hopefully they'll be able to fix that right up.
The Astronomy Daily Podcast
with Andrew Dunkley.
Now, one of the ice moons that we've talked about previously, Enceladus, is a pretty exciting place because of its vast under-ice oceans. And it is the subject of much speculation as to whether or not there are living creatures inside the planet, which they hope one day to visit. It's starting to look like Enceladus might be more habitable than we thought. We know that a world doesn't need to be within a star's habitable zone to have liquid water. The large moons of Jupiter, like Europa and Ganymede, have warm interiors thanks to tidal forces. So being in the Goldilocks zone as such is not mandatory. And the same can be said for Saturn's moon Enceladus. So, it stands to reason that it too has a warm interior and may well then have plenty of liquid water for life to get the nutrients it needs to survive. So it's all speculation at the moment, but it is looking more and more like Enceladus is a prime candidate in the search for life beyond Earth. That seems like a good place to wrap things up. Anything to finish off this week for you, Hallie?
Yes. Did you know that a full moon is 9 times brighter than a half moon?
No, I didn't even think about it. If someone asked me, I would have said twice as bright.
When the moon is full, it means that the Earth is between it and the sun. Therefore, shadows cast by objects on the moon are pointing away from us, hidden from view. So we see the maximum amount of the moon brightly lit. However, a half moon means that many objects on the surface are in shadow from our perspective, so the light reflection is decreased by much more than 50%.
Oh, yeah, that makes a lot of sense. Thank you, Hallie. You have a good weekend. We'll talk to you next week.
Okay. Bye. Bye.
Oh, I think that was supposed to be bye-bye. Anyway, it kind of worked. Thanks, Hallie. And from me, Andrew Dunkley, thanks for listening to Astronomy Daily. We will be back again next week. But in the meantime, you can catch up with all those stories and more on our website, spacenuts.io. Click on the Astronomy Daily link up the top and you can read all about it. You can also subscribe to the newsletter. It's absolutely free and it'll pop into your email on a regular basis. So check it out. And listen to the latest episode of Space Nuts, episode 323, while you're there. It is out now. Until next time, from me, Andrew Dunkley, this is Astronomy Daily.
The Astronomy Daily Podcast
with Andrew Dunkley.